Okay, good evening, everyone.
Good
Uh,
evening, sir.
so last class we completed the structures that are related to looping statements, like we have seen for loop, while, and do while. So today we'll see a few programs which are related to these looping statements. Okay. Okay. First we'll see. So this is my task. So I'll be given a number. So I'll be given a number. So my task is to find the sum of all the digits in that number. Okay, suppose if the number is like this, so 236. So my task is I just want to find the sum of all these digits. Like I'll calculate like this: so 2 plus 3, so 2 plus 3 5, so 5 plus 6. So the final answer is this one, 11. So user will give any number. I'll say that number as n, and I'll try to find out the sum of all the digits. Okay, so this is the task here. Okay, so first I'll start with hash include stdio dot h. So I'll start my main function. Now what I'll do is so I have to declare some variables first. So what variables I require here? So I need the value of n, and I require, so after finding out all the sum, I need to store it in some variable. I'll say it as a sum, and I'll initialize the sum with 0. Okay, so I'm just reading the value of this n. Enter any number. So user will enter a number. I'm reading this number now. So user has given me, let us say user has given me some number n, and this number is like this 1.
Hello,
Hello.
sir. Your screen is not visible rightly. It's blurring and not running.
No, is it not visible?
Now it is visible, sir. I think your
It is
internet is
visible,
slow.
sir.
Maybe. Okay, so I have a number like this. So 147. So first of all, what I'll do is, so first I'll try to find out the last digit in my number n. So what is the last digit in the number n? So what is the last digit in this number n? So how I can calculate the last digit is, suppose if I have a number, like any number you take, and if you try to divide this number with a 10, so it will be divided by 14 times, and it is 140, and you'll get the remainder as 7. Okay, so this is your reminder now. So how you can get the remainder for n? If I say remainder is equal to n modular 10. So modulo is one operator which will give you the reminder value. If I divide any reminder with this 10, sorry, if I divide any number with a 10, I will get the, obviously I will get the last digit in that number. Okay, if it is 147, I'll get 7. If it is 150, if I get 155 is my number, and if you divide it with the 10, so what you will get? So it gets divided by 150 times, sorry, 15 times and 150, and you'll get the remainder 5. So I got the remainder, that is the last digit. So when I divided any number with the 10, the remainder is the last digit. Okay, so after getting the remainder that is the last digit, so now what I'll do is I'll add that with sum. I'm adding that remainder value with sum. So sum plus remainder, and again I'll place the sum into the same variable. That means sum is equal to sum plus remainder. So initially my sum value is 0. When I add this 7 to this 0, it becomes 7. Okay, so that means I have added the last digit in the number. If any number you can take, when you divide it with the 10, and then the remainder, you'll get the last digit. So adding that remainder to the sum. So now out of 147, I'm done with the last digit. Now I want only this number. So see, this number I want. So how you'll get this number? I can say n is equal to n by 10. So this is a normal division. The first step it is, this is modular division. So where you'll get the remainder. This is a normal division where you'll get the coefficient. You'll get the quotient when you divide, when you do a normal division, and when you apply the modular division, you'll get the remainder value. So that means now your n value is 14. Again, I'll repeat the same procedure. So you try to divide this 14 with 10 again. So how many times you can divide it for one time, and the remainder is 4 this time. Now you go and add this 4 again to sum. Already sum is having 7. 7 plus 4, it becomes 11. And so I'm also done with the last digit, which is 4. Now I want only 1. So this is 1. So that means when I say n by 10, again I'll get this one. So I have to iterate this procedure. I need to repeat the same procedure of finding out the last digit, adding that last digit to sum, and ignoring the last digit. So you can ignore the last digit by dividing that number with 10. By dividing that number with 10, you can ignore the last digit. So you need to repeat this procedure. So up to what time you need to repeat this procedure? Up to what time you need to repeat this procedure of finding out the last digit, adding it to sum, and ignoring the last digit? So when you can stop it? Hello? Hello?
Hello?
You able to, am I audible or not?
Yes, sir, audible,
Okay, fine.
but I didn't understand.
Okay, fine. So you need to repeat the procedure of, suppose you have a number like this. Say your number n, you have a number n. So you understood what is the actual task here?
To divide.
What is the actual task? What is my actual task here?
Sum of the last sum of digit in a given number.
That is what I have written. What it means. What what is meant by sum of the digits in the given number?
Last digit.
Hello.
Hello.
So my task is to find out the sum of the digits in the given number. Okay. So it means if I was given any number like this, I want to find out the sum of all the digits, that is 1 plus 4 plus 7.
Addition.
Hello, sir.
Hello.
Sir, can you please repeat once again the program?
Yes, yes, repeating the same thing. So the task is, if I was given any number like this n, I just want to find out all the sum of the digits. So what are the digits in this number? 147, 147. I'm just trying to find out the sum of those digits, sum of those numbers. So I want this as my answer. This 12. If the number is 153, I want to calculate 1 plus 5 plus 3. So got it?
No, sir.
Hello? Hello?
Hello.
You got this one or not?
No, sir.
What you didn't get out of 153, 1 plus 5 plus 3? You don't know additions?
Yes, sir. No. Sir, I know.
Look at the problem first. I will be given a number like this. I want to find out the sum of the digits in that number.
Sir, in any
What are
number, we should just add.
what?
In any number we will get, we should just add in.
Yes, that's what. If the number is 146, 1 plus 4 plus
11.
6. What you didn't get in this?
Now, sir, I got it.
So this is the task here. Okay. So for this task, what I'm doing here is, so suppose let us say I was given a number, let's say 1, 2, 3. So out of this 123, I can do 1 plus 2 plus 3, or I can do 3 plus 2 plus 1. Anything is fine, right?
Yes, sir.
So it is easy for me to find out or identify the last digit in any number. How I can identify the last digit is, suppose if I divide any number with 3, sorry, if I divide any number with 10, the remainder is the last digit in that number. You take any number and you try dividing it with 10, the remainder is the last digit of that number, because 10 I can divide it with 12 times 120, and the remainder is 3. So once if I get the remainder, so how I get the remainder is when I apply modular division. So modulo is one operator, so where I can get the remainder of that number. So after getting the remainder, I'll take one variable called sum, and I'm initializing this variable sum with 0. So now add, so what is the previous remainder now? 3 is my previous remainder. Now simply add this remainder to sum. So sum is already 0, 0 plus 3. Sum value is 3. So got up to this point.
Yes, sir.
So now out of 123, I have already added the last digit to sum. Now my task is, I just want to ignore or remove that last digit from my number, because the last number is already added. So I don't want to consider that number anymore. So to ignore that digit in that number, you can apply a normal division with a 10. Previously I have applied modular division. Now I'll apply normal division. So when I apply, what is the value of n? It is 123. 123 divided by 10, you will get the coefficient as 12. Applying your n value by ignoring the last digit. So from 123 it becomes 12. Got it?
Yes, sir.
Yes, sir.
So now I'll repeat these 3 steps. Again, what is the value of my n now? It is 12. So divide this 12 with 10. So what is the remainder now?
2,
Add this remainder to sum. What is the value of sum?
3,
Add the remainder to sum. Sum is already 3. When you add it to it becomes
5,
5. So now this last digit is also added. So I want to ignore this last digit. If I apply normal division with 10, so 10 ones are 10, so you'll get the remainder as 2. So when you apply normal division, so what is the quotient here?
1,
So your n value is 1, n equal to n by 10. Okay, still I have one more digit in that number. So I can apply this division operation. Apply this division operation with a 10 on the number 1. So how many times? And the remainder is
1,
1. So add this remainder to sum.
6,
So the sum value becomes 6. Now, what is the value of n by 10? Your n value is 1. 1 divided by 10. What is the value here? 0.
0.
So, do I have any more digits here?
Hmm.
Do we have any more digits in the number n?
No.
No, sir.
No, all the digits from 123 it become 12. 12 it become 1. So 1 it become
0.
0. So no more digits. So I can stop my procedure and I can simply display the value of this sum. So that means you need to repeat these three steps. Up to what time you need to repeat these three steps? When the value of n becomes 0, you are stopping. That means when you are doing, you are stopping this procedure of calculating the remainder and adding to sum. So all this procedure you are stopping when the value of n becomes 0. That means when you are doing this procedure, when the value of n is not equal to 0, that's it, right?
Yes, sir.
Yes, sir.
So simply I'll repeat this procedure while the value of n is not equal to 0. So what I'll repeat these three steps. And once if it becomes 0, I'll simply go and display some of the digits in the number as percentile d. So that is in the variable sum. Okay, I have to declare this variable reminder. So every variable you use in the program have to be declared. So enter any number. So I'll say 2, 3, 4, 5. It will calculate 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14. Got it?
Yes, sir.
Yes or no?
Yes, sir.
Okay, so this is what sum of the digits in that number. Okay. Next, we'll see one more program.
Sir, can you show the code again?
What?
Sir, can you show the code again? Last one, down part.
Which one? Hello? Which one?
The last one on printf.
So printf is just for displaying the value. It will simply display what is the sum of those digits in that number.
Okay, sir.
Okay. So next one is I'll try to display a series of numbers. So that series of numbers is called as a Fibonacci series. That series is called as Fibonacci series. So what actually mean by this Fibonacci series is, so first I'll tell you what the series is. So the series looks like this. It goes on like this. So you understand what is the logic in the series? So the first two,
Adding,
hello?
Got it.
it is adding the numbers, right, sir?
Ah,
U,
yes,
U
yes.
plus 1 plus 1 2, 2 plus 1 3, 3 plus 2 5, 5 plus 3 8, 8 plus 5 13.
Mm. So the first two numbers in the series are 0 and 1. These are the first two numbers in the series. Okay. So later on, this number from the third term, the third term is sum of the first and second terms. Fourth term is sum of second and third terms. Fifth term is the sum of uh, third and fourth terms.
So when
So like that. Suppose if you want to calculate nth term, so what you'll do? You want to calculate nth term in that series. I'll simply sum up the values of n minus 1, n minus 1th term and n minus, that's simple, right? Suppose if I was asked to display like 5 numbers in this series, 5 numbers in the series. So what I'll do is I'll see, look at the logic. So concentrate more on the logic here. I will take two variables. First one is I'll say it as a equal to 0 and b is equal to 1. So these are the two default numbers in the series, first two terms in the series. And I will take a variable called count. I'll take a variable called count and I will simply initialize this count to 0. So if I was asked n numbers, that means 5 terms in the series. Every time I'll try to display the value of this a. What is the value of a?
0.
So I'll display the value of a, that is 0, and I will increment the count value to 1. That means I have displayed one term in the series. Count will always indicate the number of terms that were displayed in the series. Okay. Now what I will do is I'll take one more variable called c, and This C is the sum of these two terms. What are the two terms?
0 plus 1.
Yes, I'm just generalizing it
A plus
like
B.
A plus B. So what is the value of my C now? It is 1.
1.
After calculating this, what I'll do is I'll just modify the values of A and B. I'll copy the value of this B into A, and I'll copy the value of this C into B. Now A value is 1 and B value is also 1 here, because I am copying the value of B into A. That means 0 will be replaced with 1. I am copying the value of C into B. This 1 gets replaced with 1.
1.
Okay. So these are the steps I'll do. And should I display one more number in the series? I was actually asked to display 5 terms in the series and I have completed only one term. So I will compare my count value with n. So count will tell me how many values were currently displayed. So currently I have displayed only one value as of now. But still my target is to display 5 terms in the series. So I have to display one more term. So there is a chance for me to display one more term. So I will again repeat the same procedure what I have done previously. I will display the value of A. So the value of A is 1. So 1 is displayed. After displaying this, I will immediately increment the value of this count. That means now, as of now, I have displayed 2 terms in the series. Right? After displaying the value of A, I'll increment my count. Now I'll calculate the value of this C. What is the value of the C now? What may be the value of C?
2.
That is 1 plus 1, it becomes 2. So now copy the value of B into A and C into B. Now A value becomes 1 and B value becomes 2. So these are the steps I will repeat regularly until my count value reaches to the target number n. Until the count value reaches to the target number n. Until it reaches to that point of n, I will repeat this procedure. Okay. See what actually will do in the program. Okay. Hash include stdio.h. So first I'll take few variables. So what are the variables I require? I require A. So A value is initialized to 0, B value initialized to 1, and I have one more variable C. And I require the n and I require count which is initialized to 0. So these are my required variables. Clear? Is it clear up to this? So printf enter the value of n. That means how many terms you want to display in the Fibonacci series. See, what are the steps I'm repeatedly doing? So what is the first step I'm doing? Hello? Am I audible?
Yes, sir.
But no one is responding. What happened?
Swaroop, Vaishnav Arya, and Chetan Sai.
Yes, sir.
Okay, first of all, I'm displaying the value of this A. So displaying the value of A here. Immediately after displaying the value of A, I'm incrementing my count variable. Count plus plus. So from 0, it becomes 1. So because the first number has already displayed in the series, I'm incrementing the count to 1. After incrementing the count, so now I'll calculate the third term. So which is the term which you will get from the sum of the two terms A and B. I'll write like this: C is equal to A plus B. So after getting the third term in the series, now I modified the values of A and B. So A value gets modified with B and B value gets modified with C. So these are the steps I'll do repeatedly until my count value reaches to n. So till the value of count is less than or equal to n, I'll do this procedure. So that means displaying the value of A, incrementing the count value, and modifying the values of A and B. So this procedure will be repeated till the value of your count reaches to n. Okay, you can make it as less than n because you're starting with 0. So if I give 5, it displays 5 terms in the series. If I give 15, it displays 15 terms in the Fibonacci series like this: 4, 5, 6, 7, 8, 9, 10, 13, 14, 15. So these are the first 15 terms in the series. So like this, it will display total n number of terms in the series. If I say 20, it displays 20 numbers in the series. Hello?
Hello.
Yes, you able to follow? Understood?
Yes, sir.
Okay. So I'll stop with this for today. So you try to practice these programs with other loops, like you practice it with a do while. Have you practiced the previous programs? I told you yesterday from 1 or 2 programs to practice with all the 3 structures. Have anyone tried it?
Yes, sir. Try.
So you got the programs.
Yes, sir. But always coming like compiling error.